It was always plain to man that the stone, clay, wood, or metal with which he built his buildings was solid matter. He could see it, feel it, cut it, weigh it, hammer it, join it. It protected him from the extremes of climate and the assaults of other men. The discovery of radiation allowed man to probe deep beneath the crystalline and cellular structures of matter. He found rigid arrangements of atoms, which are themselves mostly empty space. Each atom is made up of a tiny nucleus surrounded by whirling electrons from 1 to nearly 100. Radiation can pass readily through an atom containing few electrons, with slight chance for collision. Collision is more likely when radiation encounters an atom with many electrons. It is this collision with an atom which reduces radiation. The greater the number of atoms encountered, the more the radiation is reduced. These discoveries made it necessary for man to re-examine his concepts of shelter, to reappraise the design, structure, and materials of his buildings. If there were ever a nuclear attack on this country, tremendous quantities of radioactive particles, fallout, could spread and blanket as much as 3/4 of the total land area. To anticipate this contingency, a nationwide survey was made by the government to determine how much fallout shelter space was already available in existing buildings. Out of the survey came techniques which can be applied to the design of new buildings. Along with all other elements of building design, architects are now considering radiation shielding. The Office of Civil Defense calls this slanting the design. Slanting can be done with little or no extra cost and without affecting a building's function or appearance. One method is to put enough mass between the area to be protected and the sources of radiation, fallout on the roof areas and ground around the building. This is called barrier shielding. Since the atomic structure of matter varies, the effectiveness of a barrier depends on the nature of the material itself and on its thickness. Atoms in wood, for example, are loosely packed and contain only a few electrons. This allows radiation to pass through easily. Atoms in concrete, by comparison, have many more electrons and are densely packed, making a more effective radiation barrier. Other design factors, including size, shape, and location, can also be used to increase a building's shielding effectiveness. This is called geometry shielding. This is the Southeast Polk High School in Ivy, Iowa. By planning for fallout protection early in the design stage, no additional costs were incurred. Classrooms are designed around a central core, which includes the library, cafeteria, restrooms, and study areas. The architect was able to take advantage of a concrete roof slab and the combination of classroom walls to make this particular area into a shelter for 1,700 people. The basement of one wing of the Somerset County Home for the Aged in Somerset, Pennsylvania, provides 1,000 shelter spaces. In this type of design, the area is already shielded by its location. Increasing the thickness of the overhead concrete slab adds enough shielding to make it an excellent shelter. The cost was less than 1% of the home's total cost of just over $1 million. This is the school administration building in Pontiac, Michigan. Here, a number of factors affect shielding. A hillside location, a concrete roof slab, and reinforced concrete walls and baffles provide 1,200 square feet of shelter area. There was no extra cost. In this Shreveport, Louisiana bank, the Board of Directors room, offices, and staff lounge cover 2,300 square feet. These rooms are protected by a below-ground location and by 6-inch thick reinforced concrete slabs overhead. So it is also a shelter for 230 people. Shelter was a basic consideration in the design and added nothing to the construction costs. Slanting the design has not affected the aesthetic form or function of the library on the University of California's San Diego campus. On the bottom floor, reading rooms, a language lab, TV studio, workshops, offices, and storage rooms comprise a shelter for 2,500 people. Again, fallout protection was considered in the basic design of the building, so there were no added construction costs. There is flexibility in any building at the design stage. Window sills can be raised or planters installed to increase barrier shielding from ground radiation. The building can be placed on a sloping or graded site, or with part of the building below ground. Walls and roof can be made into more effective radiation barriers by using thicker concrete, solid concrete blocks, and by filling the holes in hollow blocks with sand. Finally, the arrangement of hallways, doors, stairwells, windows, and building facilities, with the addition of baffles if necessary, can provide a shielded area. A building is material: concrete, steel, brick, stone, glass. It is a geometry of roof, walls, and interior space. It is also ideas, concepts, and techniques. And one of these is slanting.